So our goal today is rates math. I used to not really even teach this. I would just say, hey, you're going to have to know this. You're like, oh, okay. Um, rate math is not very hard. It's the only math in this entire lab book. It doesn't require a picket fence. It's just one single equation. Now, sometimes there's additional parts to the equation, but it's really not that awful. All right, so today we'll do rates math. If we end up having more time than first hour, we will start setting up for our lab we're doing tomorrow. All right, the lab tomorrow is not that hard, but you have to do it on your very own. All right, so here we go. Rates math. First off, we are going to do the rate math on the front cover. There's just white space. That's where we'll do it. But don't go there yet. We're going to do the first paragraph on page 2. I know. I looked at Sam. He's like, why'd you make me do that? Thank you, Fred. All right. So I don't actually have the paragraph in the notes right here. But I do know that the first word is, or the first blank is the word rates. So on the top of page 2, go ahead, you're good. Top of page 2, our first word of this lab book is a blank. It's the word rates. Now, I don't have it memorized, but I kind of have it good enough. So rates measure changes over intervals of time or something to that effect. All right, then it just straight up, hello, Mr. Allen. It straight up gives you an example. It says, for example, if you were to drive to St. George in 300, or sorry, which is 300 miles in 5 hours, then it says your rate is 60 miles per hour. We've done that a ton. We've driven on roads. We've calculated our speed. Every road trip, you've done the math probably and worked from there. So you're used to miles per hour, which is really miles per hour. And you just plug the math in, 300, 5, and 60. This is all we're going to do today, but it's going to sound complicated because we're going to use chemistry words. All right, give me like 1 minute. All right, here we go. Of course you can, my friend. You got to go, that bladder. All right. I did hit 210 again this weekend. Oh, man. Okay. You don't care. Next. So, are you all right with miles per hour? You do it. I know you've done it. Don't don't overthink this. Like I'm going to use the word moles, grams, and molarity, and then you just are like, screw it. I hate chemistry. All right, moving on. Here we go. Instead of units length like miles and time hours, reaction rates are expressed using chemical units like moles, grams, and whatever. So the next blank is units. All right, thus, a small sheet of metal containing 1 mole of iron might rust at a rate of 0.5 moles. And then put slash and whatever your favorite time unit is right here. Second, minute, hour, day, week, month, year, decade, millennium, whatever you feel like. You okay with that? Please don't overthink it. I swear, maybe I should test that hypothesis. If I didn't teach it at all, I swear you do better on the math than if I do teach it. Like when you learn variables, like in 3rd or 4th grade, is that about the time they throw in a letter? You're like, what in the world? They almost always use speed as your example. That's like how they teach a 3-variable equation. But whatever. All right. Then we can also measure reaction rates by timing how long it takes a change to occur. So there was a blank right there. It's just rates. Or is it chemical? Reaction rate, sorry. Someone say my name? Okay. All right. And what we mean by that is, so in the lab tomorrow, you have your test tube. All right. You're going to put your hydrochloric acid in here, and then you'll drop a square of magnesium in it, and it will start to bubble. And we're going to measure how long it takes for the square to disappear. That's all. We're not going to do any math. We're not going to like calculate how many grams there were and all that. It's just a relative comparison rate. It was there at one point, now it's disappeared. How long did it take to do that? So that's that. Okay, now, if you would, just shut the cover and look at the front. What we're working on today is this 6th thing right here. Quantitative properties of reaction rates. Quantitative properties of reaction rates. This is the only math, and it's just multiplication and division. Sometimes there's subtraction too, I guess. But when we do this, we use a pretty simple equation, and it is that rate is equal to change divided by time. This is the only one we'll use over and over and over. What's that? It's exactly like density. It is 3 variables where one is equal to 1 over the other. And we can put it in these circles. If you had me for first try, I definitely taught you how to use this circle. I believe the other ones do, but if they don't, it's fine. I put these things in circles so you don't screw up algebra. The way the circle works, if you have a 3-variable equation, the thing on top, like change, is the thing you draw on top of this circle. So it's just a circle with a T in it. And then you take the top part, put it in the top, and the other 2 pieces go on the bottom. That's all you do. Now, to use it, you find out what the problem wants you to solve for, and you cover it up. Once you cover it up, whatever's left is the math that you would do. So if you look right here, you'll notice rate is equal to change divided by time. If you look right here, if I cover up rate, you'll notice it is rate over time, or sorry, it's change, can't speak. It's change over time, or change over time. Okay, if you wanted to solve for change, I keep doing that, you would cover it up. And that would leave the rate times the time. If you wanted the time, you'd take the change over the rate. The change is always measured in grams or moles or molarity. So if it asks like, how many grams can be made, that would be the change. It's like, hey, I have this rate, this time, how much can I make? All right, like you've done that with your job. If you work, what's minimum wage now? 7.25. Okay, that would be your rate. And then you know you're scheduled to work 24 hours next week. So how much money you make is just those two numbers times by each other. Everyone with a job knows how to do that math, right? Sam, you ever calculate how much you're going to make? No?
They do it for us. So.
Oh, well, this world, back in my day, back in my day, by the way, I hated my job so much. I did the math to find out how much I made per minute. And it was not, it was very depressing how much I made per minute. I'd look at the clock and watch the second time go around. I'm like, I just made 7 cents. That's depressing. And there was a microwave that had a timer on it, and I would just look at it like, I just made 7 cents. Okay, I'll shut up. All right, so anyway, the math isn't super complicated. You've done it before. It's just vocabulary. All right, two practice problems. It says how many grams of copper. So I just said the unit of change will be grams. So I'm going to cover change up, which means whatever I'm left with, I'm going to multiply. I'm going to multiply the rate times the time. So how many grams of copper will react in 30 days? So that would be my time. If the reaction rate, the rate of reaction is 0.25 grams per day. So I literally just take the rate, multiply it by the time, 0.25 times 30, and I get 7.5. That wasn't awful, was it? Okay, try that next one. You'll need a calculator today. You can use your phones as long as you don't just spend the rest of the day on Snapchat, which probably isn't as cool as it used to be anymore. So is it TikTok? That's the cooler thing now? But you're wrong. How rude am I? Well, your math was fine. Does anyone know why Kieran's wrong, but she's right? Emery? No? She what? Yeah. Well, no, that's not right. But the units are involved. Hello, my friend. I knew, I sensed. Okay, here's the deal. This tells you the rate is 0.015 per minute, but it wants it in how many would react in 2 hours. So here we go. The rate is 0.015. The time This was in minutes, so this has to be in minutes. This is 120. So probably everyone just multiplied it by 2. Did anyone multiply it by 120? Okay, so make sure you just read careful, because chemistry is really good at screwing over your lives. What's that? That's not the answer, but yes, the time is 120 minutes. All right. Fair enough. There are, well, I should say there is. There's one more type of question, and we'll see on the next part. Sometimes, and it's only, hold on, go away. I need to get there. Fine. It's only when we solve for change, usually. Sometimes the problems will give you the rate as 2 separate numbers. So it will say, I made, I don't know, $30 in 2 hours. How many in 6 hours? Now, that one we can probably just do in our head, but when we throw in moles and stuff, once again, it's a little tricky. So the rate, if you look, the rate is 30 in 2. So sometimes you have to calculate the rate first. Now, 30 over 2 is really 15, right? And then I multiply it by 6, and I get that I can make $75. That's not right. That was not right. It's $90. Okay. So once in a while again, and on the next page there's one, it gives you a rate that you have to calculate first, and then you plug it in. Okay, these right here, 4, 4B, 4C, 5, 6, and 7, these are on page 10 of your lab book. These are your homework problems. Now, 4 and 4B and C have nothing to do with each other. I added them this year, but I didn't want to renumber every homework problem, so I just cheated and put the B and the C. So they do not relate to each other. Page 10. So you'll use this same idea, work through these. There are some of them that a lot of people got wrong last time because of the time. So look at number 6, 2 minutes but per second. Okay, so be careful, make sure your times match up. And I'll give you 10 minutes, see how that goes. All right, keep going. I forgot I was recording, so onliners are probably bored out of their minds right now. Let me pause. It was found that 7 grams of zinc completely react with acid in 30 seconds. So 30 is definitely a time. That's a little bit too thick. All right, 30 goes here. And then the change, the amount that reacted is 7. So 7 divided by 30 was 0.23. Raise your hands if you had 0.23-ish at least. Okay, good. Next, 4B. This is a 2-step one. 15 grams of water decompose in 20 minutes. These are trickier because the rate is given to you as a mathematical relationship. So 15 over 20, or you could just put 0.75. How many grams of water would decompose in 35 minutes? So you take 15 divided by 20, which is 0.75, and multiply it by 35, and you get what answer? Help me out. 0.625? That 26. Okay. Good enough. All right, 26.25. All right, 4C. This is just like this one, just like it. In a reaction of magnesium with hydrochloric acid, 6 grams can react in 5 minutes. So that's your rate, 6 per 5. So you could put 6 over 5, or you can just put 1.2. That's what 6 divided by 5 is equal to. So my rate is 1.2. How many grams? Anytime I ask that, that's solving for the change. React in 10 minutes. So 1.2, did I do something wrong? Nope. So what do we get? 12. Okay. Then number 5. It is known that the rate of magnesium reacting with hydrochloric acid is 0.05. That's nice. It just gives it to me. The rate is 0.05. And that the reaction takes 5 seconds to occur. Well, how nice is this problem? Determine the number of grams that have reacted in this case. So it's just these two multiplied by each other. If it asks for how many grams, that's the change. So 0.05 times 5 is 0.25. Easy enough. Okay, number 6. This is the one most people get wrong, but it's just because that decimal is really, really small. So don't stress about it. And then also it's minutes and seconds. After 2 minutes, 0.5 grams of calcium react completely with HCl. Calculate the rate of this reaction in grams of Ca per second. All right, so I want the rate, which means it's the change, that's the mass. So 0.5 over time, which is 2 minutes, but it wants per second, so it's 120. So it's 0.0041-ish, if I remember right. Okay, then number 7, this is something that kids are losing. I did not know this. Most people the first hour did not know. There are 52 weeks per 1 year. You should just file that away in it's smarter than a 5th grader, whatever the show's called, knowledge. All right, if iron reacts to form rust at a rate of 1.12, so that's my rate. How many grams would rust in 52 weeks? These have to match each other. So 1 year is 52 weeks. If we want the change, it's rate times time. So 1.12 times 52 was 58 point something. 24. Good. Okay. That's that. The last 10 minutes, I want you to go to Canvas, grab a lab book, and see if you can beat first hour's average. Not a lab book, an iPad, sorry. You're going to take this quiz in the How Fast, it's called How Fast Math. Arriving at an average of 85%. It's much better than first hour, who had an average of 51. It's okay. I mean, that's their right to not do well in a quiz. So anyway, good job. Hopefully that went well. And that is all the math for our test.